Hi, so my name is Jamie Cummings. We are from Arizona State University, and this is our presentation. Let me see. Okay, so our team members are Delano Dunbar. He was the team leader. My name, Jamie Cummings, Trent Molesworth, and Anastasia Muir. Our approach to this project, sorry, there's a little bit of lag. So Delano was, like I said, the team leader, but he also worked on the financial analysis. I worked on the conceptual system design. Trent worked on the distribution system impact, and Anastasia worked on the development plan. For the system design, we met remotely the entire time. We're all in different states. Delano was able to attend the first conference, the Solar Power International. And I work currently in the consulting field for Electrical Consultants, Inc. So I have some experience with solar from that. So interestingly enough, I am very used to Arizona's sun, California sun, and because of that, we were a little inexperienced and somewhat optimistic about the results. We work with some of our PV fields have 250 megawatt production, and that is not close to what we arrived at here at BSU. And we also struggled a little bit with the planning of the battery addition. We expected to be able to store the off-peak excess. Here's the deliverable package. You'll see this is the site for the ground-mounted installation. This is actually not the updated drawing. In the updated drawing, you'd be able to see exactly where everything is placed. And that will be the same case for the building mounts. But here we have a screenshot from Aurora. And you can see what we did to simulate the usage was take every use case and combine them that we had for Ball State and use that as our usage for this particular area. And we arrived at about 5 megawatt hours for the ground mount. Again, like I said, this is the building site. And this particular one is Robert Bell building. And you can see here all of the arrays. Now we kept generally the spacing between them is about, let me double check. I believe we kept about 72 inches between the rows to prevent any shading, but minimal spacing in between, about 12 to 24 inches. And the panels are tilted at 55 degrees almost everywhere, facing due south.
So when it came to using OpenDSS, we relied heavily on Trent and his earned expertise through this competition. This here is the initial model. It shows the Ball State University's system without the addition of any solar PV. And then once we were able to get our solar PV, we were able to model it and show that we weren't reaching any peaks. I think we're fighting over control of the slides. So we were able to, oh no, my slides are running away with me.
Sorry, Anastasia, please reset and I'll leave the clicker alone on my side.
Okay. Okay, there we are. So we were able to show that we were not exceeding any max or min settings with the distribution system. When it came down to the financial, we using the Solar MBA demo that was provided by the heat spring training was absolutely phenomenal for coming up with a financial model. Using the model, we were able to come up with these tax benefits and our the debt versus the operating cash and show that we weren't getting quite the benefit that we were hoping for from the panels, the solar panels. And it was going to slowly grow, but we were only getting about a 2% efficiency from the panels. So we only had a 2% per year growth on the PPA, which over 20 years is still significant, but we were hoping for a bit more. A big part of my contribution to the overall project was the development plan and searching through all of the different maps to make sure that where we were planning to build the ground-mounted arrays would be ideal and that we wouldn't have too many financial problems having to grate or having to shore up if there was sandy soil. And we wanted to make sure that we weren't going to have any problems with tree shading. So we came up with an initiative to plant a tree for every tree that was cut down. And we also found that across from the Ball State University buildings on campus, there is a Westwood Historic District, and we wanted to ensure that the buildings we were placing these solar panels on were not going to affect the aesthetic of that historic district, because then we would upset the residents, and we didn't want to have any sort of pushback or any sort of negative influence, because then we wouldn't have the support of the community that we were hoping for that would help us to build these panels on time. And our construction schedule, with building the panels and installing everything at the ground mount and the buildings, we were looking at 32 weeks to complete construction, which is a bit of a stretch, but we didn't want to build everything at the exact same time, so we sort of staggered it so that we would impact campus life less. Now, using the Aurora simulation, we were able to adjust the system losses and wiring so that we could optimize our design and get the most out of it. And even with that, we wanted to maintain realistic values. We didn't want to be living in some beautiful ideal wonderland. We wanted these numbers to be real. And when we came out, the overall system operation for the ground mounted, we were able to get a 7% energy offset from our 4.1 megawatt system. We were able to do this with our almost 9,000 panels that are spaced 120 inches, so 10 feet between each row to avoid shading. Our losses, however, always seemed a little higher than I think we wanted. So our yield wasn't as high as we had really hoped. We were looking for at least 100 megawatts, and we never got anywhere close to that with our system design. But we were able to maximize the usage of the 13-acre ground mount installation site and produce 4.1 megawatts. Using 7 of the rooftops on the campus instead of the 29, I believe it was, that were available, the cost was too high to make up for the benefit of using the rooftops. So we only utilized 7, and on each building we averaged about 3% annual savings. So we weren't able to get the total production that we had hoped for. And that is the end of our summary. Thank you.